Clock's ticking, and it's been ticking for a while now, and it's probably time to get.
The landscape of Southern California is fractured like a huge letter Z. The top arm is made up of a winding network of fissures that caused quakes that shook the city of Ridgecrest. The diagonal section is an ancient fault known as Garlock, which runs west. And along the bottom sits the mighty San Andreas. Seismologists have been worried about California's next massive earthquake, called the Big One, for years. The natural disaster was even made into a large-scale earthquake drill by a team of experts from the US Geological Survey. The drill, dubbed the California Shakeout Scenario, simulates a magnitude 7.8 earthquake striking the San Andreas Fault in Southern California, which has long been assumed to be the location of the Big One. Around 30 million years ago, the North American plate consumed virtually all of the Farallon plate, forming the San Andreas Fault Line. Since then, the North American plate has collided with the Pacific plate along a boundary known as a strike-slip fault. To truly grasp this fault line and the risk it poses to unwary Californians, you must first understand more about its topography. So just what is the San Andreas Fault Line? The San Andreas Fault Line is a continental transform fault that runs through California. It is approximately 1,200 kilometers long and serves as the tectonic boundary between the Pacific and North American plates. Experts characterize its motion as a right lateral slip motion, which implies the two plates are gently sliding past one another horizontally. The fault is separated into 3 distinct segments, each with its own set of features. Another significant difference between the 3 portions is the varied degree of seismic danger. The annual slip rate between these fault lines is between 20 and 35 millimeters. Andrew Larson, a UC Berkeley professor, was the first to discover it in 1895. Most people believe the northern zone of the fault was named after the little lake that formed in the valley between the 2 plates called the San Andreas Lake. However, publications by Lawson published between 1895 and 1906 imply he was the one who named it after the adjacent San Andreas Valley. Lawson deduced that this fault stretched all the way into Southern California after the 1906 earthquake in San Francisco. Experts think this large crack in the Earth's crust formed over 30 million years ago in the mid-Cenozoic era. Multiple significant earthquakes occurring near the plate's surface have been linked to tectonic action along this fault. According to Tectonic Theory, the San Andreas Fault represents the strike-slip border between the Northern Pacific and the North American plates. The Northern Pacific plate appears to be sliding laterally past the North American plate in a northerly direction. The 3 fault segments are known as the Northern, Central, and Southern segments. The northern portion begins in Hollister and ends at the Mendocino Triple Junction. The middle part extends from Parkfield to Hollister, while the southern segment extends from Parkfield to the Salton Sea. Geologists have indicated that compressional forces are being generated by the southwestern movement of the North American plate towards the Pacific plate. These forces are most strong at the location where the San Andreas Fault has been shifted westward by the North American plate. The vast majority of Californians call the area around this fault home, and in a few localities, citizen roadways are actually constructed directly on top of it. San Francisco's BART, Bay Area Rapid Transit, has built a tunnel directly through the fault zone. The plates don't slip on a yearly basis, rather pressure from the compressional forces builds up over many years before slipping in the form of one really huge earthquake. Scientists' constant vigilance over these fault lines is motivated by the earthquakes they cause. It is obvious that majority of this fault line is buried under buildings, putting residents in continual danger. If you take Interstate 5 north out of Los Angeles, you'll eventually reach the Tejon Pass, which is located directly on the fault line and where you may observe artifacts from the earthquakes. On the roadway, one plate is clearly visible scraping past the other. The grey metamorphic quartz monzonite shown here is from the Pacific plate, whilst the rich brown sediment sandstone and the siltstone is from the North American plate. These two rocks could not have developed together on their own. they only emerged as a result of the sliding movement of the two plates. A layer of black rock, sometimes known as fault gouge, sits in between the two. If an earthquake were to occur here, the Interstate 5 would likely be severed, cutting off the main transportation route to and from Los Angeles. If you go north into the central Californian Valley and then west, you will reach the Carrizo Plain, which is largely rural and has little or no development across the fault line. However, the Elkhorn Scarp is the ideal site to observe the fault line from above, as there is significant dip between the boundaries of the two plates here. Interestingly, the movement of the plates also leaves its imprints on the surrounding waterways, as rivers that cross the fault line tend to have their courses altered with movements over the years. According to seismologists, the southern part of the San Andreas Fault system has not seen a substantial release of pressure since the year 1857, making it only a matter of time before the fault causes a large-scale and potentially devastating earthquake. The question is, when will this occur, and what factors have led experts to this conclusion? Director of the Southern California Earthquake Center, Thomas Jordan, made a disturbing proclamation a few years ago. According to him, the San Andreas Fault is apparently in a critical state and can generate a huge earthquake at any moment. The southern portion of the fault line looks locked, loaded, and ready to go. The prominent seismologist noted that the stress is always building because the Pacific plate is moving faster than its counterpart, even though both plates are moving in a roughly northern direction. The 1906 San Francisco earthquake and the 1989 Loma Prieta earthquake both released some of these pressures, although the southern part of the state has been spared thus far. In light of this, experts are expecting a large earthquake to hit the area soon. The US Geological Survey estimates that major earthquakes occur once every 200 years, but we have no way of knowing when they will occur. One thing is certain, however: an approaching earthquake along the San Andreas Fault Line will cause extensive damage. Larger earthquakes are possible along the San Andreas Fault's central zone than was previously thought. The fault moves slowly in a process known as seismic creep between the towns of Hollister and Parkfield, releasing stress without triggering significant earthquakes. Nonetheless, studies have shown that this area may have been hit by high-magnitude earthquakes in the past. New Zealand earthquake scientist Genevieve Coffey claims that the most recent significant tremors on this section of the fault happened during the previous 3 million years. She also thinks that the stress here at the fault, while unlikely to increase to the point where it generates a big earthquake, might serve as a conduit for the quakes that originate further north and south along the fault line. While it's difficult to pin down exactly when the big one will strike, seismologists nonetheless make it a point to provide a prediction of the possibility of such an event every few years. More than a decade ago, seismologists simulated the ground shaking along the southern half of the San Andreas Fault, and now environmental scientists and engineers utilize this data to assess the impacts of a hypothetical earthquake of 7.8 magnitudes. The repercussions of such an earthquake in California, according to their speculations and other simulations, are expected to be disastrous. So if it breaks and the big one does hit the Coachella Valley, what will happen then? To start, let's have a look at this earthquake simulator created by the California Academy of Sciences. Aside from the San Andreas, numerous additional fault lines run through the coastal region of California, creating a complex network of potentially dangerous fractures, as shown here. Despite the fact that the Hayward Fault, which is nearly parallel to the San Andreas Fault Line, responsible for much of the movement between the plates, Hayward has scarcely moved since the 1869 earthquake. If a fault in California were to fracture at a distance of just 50 miles, the resulting earthquake would be around 1/16th as powerful as the San Francisco earthquake of 1906, as demonstrated by this simulation. How much ground movement it causes will depend on factors including soil type, mountain proximity, and more. Scientists use these parameters to determine the magnitude of the earthquake shaking. The repercussions of the 9.2 magnitude earthquake that originated on the Cascadia Fault Line and spread over the Pacific coast can be seen now. You can see how a tsunami travels from Asia to New Zealand to Australia to Latin America after first striking Hawaii, and then being reflected back to the west coast. Experts predict the big one will strike the state with similar strength. But there's a 99% likelihood that an earthquake of magnitude 6.7 or higher will strike California in the next 3 decades, and a 46% chance that the quake will be of magnitude 7.5 or more. Recent forecasts put the maximum magnitude of this impending earthquake at 8, and widespread destruction remains a real possibility. If the hypothetical model for a 7.8 magnitude earthquake with sliding of 2 to 7 meters is accurate, the construction spanning the fault will be hit worst. However, because to the Alquist-Priolo Earthquake Fault Zoning Act, there aren't many buildings going up in this area. This earthquake will also damage the 90 fibre optic cables, 966 roads, 39 gas pipelines and 142 electricity lines that run through this area, in addition to the construction. The cost of fixing the damage to buildings is estimated at $33 billion, with newer structures faring better than their older counterparts. Fires of comparable intensity to those that broke out following the Northridge earthquake are expected, according to experts. In fact, it is likely that the damage caused by the fires will exceed that caused by the earthquake itself. The estimated number of fatalities ranges from 1,800 to 2,000, according to analysts. There will be hundreds of fires and the roads will be impassable. If the water supply is compromised, it will be very difficult for firefighters to extinguish all the blazes. Los Angeles water, gas and power lines will be cut, and they won't be repaired for months. The earthquake will leave the new structures standing but uninhabitable. The valley will continue to be shaken by tremors over the next few days, which might cause more damage. To add fuel to the fire, several experts at the Pacific Northwest Seismic Network believe that aftershocks from these quakes might set off tsunamis. As the water from these tsunamis crashes inland, it will inevitably cause floods. Not only will buildings endure unimaginable devastation, but so will bridges, railroad lines and highways, all of which will impede or even prevent the timely arrival of outside aid. Damage to public transportation systems will be catastrophic, and in the weeks following the disaster, it is likely that very little or no public transit will function at all. There will be substantial holdups for emergency vehicles, including fire trucks and ambulances. Numerous experts have made it quite clear that devastating earthquakes are an inevitable part of life in California, and that the best people can do is prepare for them. How long do you think it will be until the San Andreas Fault Line breaks and causes a devastating earthquake in California? Drop your thoughts in the comments below.